There we go. Hi, everyone. It's me, Alex Coulomb, your friendly neighborhood Unreal Engine VR guy. And I'm very excited to be here with you today in New Orleans talking about virtual reality and OpenXR in UE5, especially because it's such a weird timing for the session. I've never done a talk like this before where halfway through you could come up to me and say, I really think you suck. And then I would maybe have to recalibrate and then change what the second half of the talk was going to be like. But also, it's nice to take a break in the middle of a longer session like this. It might work out great. We'll see. So, introduction. Again, name's Alex Coulomb. What is something you might want to know about me? I've been an Unreal Engine authorized instructor for the past 2 years, working on all manner of course development and instructor-led training. And that's what that little logo looks like. It's really fun. You become an authorized instructor, and they're like, you're allowed to use this logo wherever you want now. I also come from a background of architecture as well as theater and theater architecture. And we've done a lot of exciting projects like the Brockman Hall for Opera here that ended up being a pretty good representation in VR before it was real. I've been working in VR for about 10 years. I started with the DK1 way back in the day. And I've spent a little longer in AR. Actually going back to my architecture thesis when I was but a young lad. And then also I run 2 companies in New York City. One is an XR creative studio that has recently done things like helped Lincoln Center's David Geffen Hall prototype what the experience was going to be like for the railing designs and the whole balcony setup, which was a really useful way to help all the key stakeholders understand what's it like to lean over different kinds of railings and position yourself ergonomically in the different seats. And that just opened very recently. Pretty exciting. And then the other company is a XR cloud streaming platform that does exciting things like this.
Mercy! Dreadful apparition, why do you trouble me?
And so what you're seeing there is actually a live actor performing in VR as a metahuman, being broadcast to an audience around the world using consumer devices like MetaQuests and being able to run the experience off of very powerful computers in the cloud. Lastly, I am recently a podcast host along with Jacob Feldman, who's here in the audience. We have the new unofficial Unreal Engine podcast. We've done 3 episodes so far, a lot more on the way. And I think we are now the torchbearers of this soon-to-be-forgotten Unreal Engine starting scene. So, with the bona fides out of the way, what would I like to talk about today? Well, I'm going to assume that most of you here have done some things in VR. You're a little bit familiar with it, but I am going to do a bit of a basics flyby because I think it's always good just to get our fundamentals out of the way. Also, this will be recorded, so I'll go through that fast, but if you're watching this as a video later on, just play it back at like 0.25 speed, and then you'll be able to take it all in at a more natural space. I really want to talk about the OpenXR templates. There's actually 2 of them. One of them was covered pretty well the other day by the technical account manager, Simon, and I'll just give a very quick rundown of that. Today, I really want to dive into the OpenXR VR template, which has actually gone through a lot of changes over the past year, especially now in 5.1. I'm going to be really dangerous today and try to do some things live in 5.1, and we'll see how it goes. As part of that, I want to talk about desktop versus mobile, different considerations for building to those different platforms, and just expanding upon what's out of the box in the VR template. Some of the VR basics we'll start with. We'll try to think about ways that we could go further with those and make something even more compelling. And lastly, I know some of you are probably here because you're curious about what's the deal with 5.1 and Lumen and Nanite. Don't do it. Don't even try it. But I'm going to show you anyway, just in case you want to be a rebel. So let's start with what's VR? Again, we'll go through this pretty fast, but presence, scale, it's like you're there. Virtual reality is, first of all, stereoscopic. Your left eye, your right eye, it gets a different view. It makes you feel like there's depth perception. It makes you feel like your eyes are actually inside a different world. It's immersive, and it can often be extremely interactive. AR is different from VR. AR is usually a digital projection of things where you still see the real world and the AR is on top of the real world. VR, typically 100% virtual. You can't see any of the real world around you. Now you have things like Magic Leap starting to dim AR to feel more like virtual reality, and things like the MetaQuest Pro, which are starting to add in other AR kind of elements on top of a camera feed, and we call that mixed reality now. But don't worry too much about all those confusing terms, especially once we get to OpenXR and what the XR part actually means. This is contentious. I like to say that 360 video is not VR. I think that 360 video, because of its lack of interactivity, the often lack of stereo, the lack of what we call a six-DoF experience, which I'll get to in a second, makes it something different. And I think it kind of gives VR a bad name. When someone shows someone a 360 video, even if it's a very well-produced 360 video, and says, this is VR, they're going to get the wrong impression. So briefly, 3DoF, degrees of freedom. That means you can do 3 axes of movement. Typically, that would be rotating your head. 6 degrees of freedom is more true VR, where you can also move on those other axes. So you have your location and your position, and those are all coming together. Some of the limitations of VR is you can't use a lot of the tricks that have developed in the camera industry over time, of course. You have a limited field of view. You can't change your focal length without potentially making people sick. You can't do as many of the screen space effects in Unreal Engine as you can when you're just using the Cinecamera actor. It's expensive to render. You're not just rendering one eye at 1920 by 1080. You're rendering 2 eyes, maybe 3 eyes, as you'll see when we get into the spectator cam. And it might be 2K or even 4K. And ideally, it's running at 90 or even 120 frames a second. So a lot more optimization often needs to go into those experiences. Also, you're always going to encounter people that, for whatever reason, they're not going to want to put on a VR headset. They're afraid it's going to mess up their hair, their makeup, their clothes. They're afraid people are going to be laughing at them. Totally fine for you guys to laugh at me when I'm in this headset. I don't mind at all, but I understand the concern that other people have. Some health warnings. People can get motion sick, they can get dizzy, they can have eye strain, neck strain, headaches. Sounds like I'm doing like a prescription pill ad. But it gets to a point where, by the way, headset hygiene, there was an ocular herpes outbreak at I'm not even gonna say which event, but like, you gotta be careful. You gotta keep these things clean. You're sharing things between people. And that also is a totally legitimate reason for someone to say they don't wanna put on a VR headset. So all things you wanna be thinking about. Best practices, just a few things to consider. First of all, if you're trying to stop motion sickness, which often is called by your inner ear not quite aligning with what your eyes are seeing, it can be caused by low FPS, by trying to like move the camera forcefully without someone actually having any agency in what's happening. It can happen from just fast movement, rotation, or position. So how can you prevent that? First of all, you could just keep the player perfectly still. You can make sure that you are just letting them walk around freely in an actual space, what we call room scale VR. You can use teleportation, and you can also use some different mechanical hardware that tends to get very expensive, but there's all sorts of aftermarket ways to help prevent VR. Or you can just tell people to take a Dramamine. But ideally, you don't get people sick in VR because VR sickness can last like a day or two, sometimes longer, and they're never gonna wanna do VR again. So don't ruin it for the rest of us who are trying really hard here to make this a thing. Some of the things that we think about with movement is the fact that teleportation is by far the most comfortable way to move someone in VR, just to snap them to another location. The problem with that is that's not how we behave in the real world. I don't, at least. I don't know about you guys, but I usually can't just pop over to the other side of the room and instantly be there. So there's a few places along the spectrum that allow us to start to make that a more comfortable experience. First one is fading to black during that teleportation, I find, can often help with a little bit of feeling more natural. Making sure that movement is not necessarily slow, but constant. Acceleration and deceleration often tend to make people feel more nauseous. Avoiding making anything, again, rotate or move in unexpected ways, and not grabbing the camera from people and moving them. If anyone's done a roller coaster experience in VR, sometimes they can be really cool, but you have to, first of all, have some good VR sea legs, but you also need to hold yourself just right for it to not feel too nauseating. But everyone has different tolerances for this sort of thing. And of course, in the real world, ideally we would just allow people to move the way in VR to match between the two, but that's not always possible if someone's in a little New York City apartment trying to make all this work. So teleporting is actually the default option. It comes with both the Collab Viewer template and the VR template, both again, which are using OpenXR. It gets handled on the pawn, quick, comfortable, but it's not realistic, and it does require a little bit of extra stuff if you're trying to set up a scene from scratch. I remember playing in Unreal Engine for the first time around 2016 with this stuff, and I couldn't for the life of me figure out why my character wasn't moving. I was like, I did everything just like the template, it's just a different scene. And I hadn't set up a nav mesh and I hadn't set up collision. So there's a couple extra steps there if you're not gonna start from a template. Quick little, I'd almost call this a fun fact. The way that people perceive the world in VR, you can hack it a little bit. There are circumferences, is that the right word? Perimeters, something like that, where if you get to a big enough size, you can make someone feel like they're walking in a straight line, even if they're actually going in a curve, which is really useful if you want to have a very expansive experience that feels like you can just go on forever. So there are some locations that are large enough to pull that off. Often, you're going to be thinking about this kind of triangle, which you see in all sorts of other things, but finding that balance between, I would say performance, first of all. You really want to hit at least 72 frames a second, more if you can. And then you're also looking at the quality and the features, and anything that starts to slow everything down is going to be kind of hurtful there. If anyone dives into something like RenderDoc, there's all sorts of tools in there to really figure out why isn't my frame rate where it should be. And we'll maybe touch on that a little today, but that's also a little more advanced. When you are designing a VR experience in Unreal Engine, it's important to think about how you're going to guide the eye. Because again, you don't have some of the typical tools like being able to move the camera and everything we're used to in cinematography. Even cuts, like teleportation is a little bit like a cut. But ideally, it's a little more like theater. It's a little more spatial, deals more with proximity. And you are trying to naturally guide the eye with stagecraft, trying to get people to look at certain things in more natural ways, audio cues, visual cues, lights. One VR experience that I show people a lot is called The Book of Distance, which is one that I think does a great job of most of the scene is black. It's not trying to overwhelm you with a huge environment, and it really helps you know what you should be looking at as that experience goes on. Newcomers in VR, you'll often find people just stand still. They'll put on the headset and they'll just look at whatever's there, and you're like, there's stuff behind you too, and they don't know to turn around. Everyone who I've given a tilt brush demo to for the first time, I find that they just stand there and they treat it like there's a canvas right in front of them, when in fact they should be, swooping through the air and dancing and acting like a choreographer. They didn't have to, but it's nice to see people understand the affordances of a medium like this that really allow for things that otherwise wouldn't be possible. And lastly, as you kind of saw with the David Geffen Hall mock-up, tactility is a really nice thing to be able to add to VR. It doesn't need to be something super expensive or complicated. You can use something like a Vive tracker, attach it to a chair or something like that, or just have a chair that's fixed in one location, and just the ability to allow someone in VR to be able to sit down and stand up and walk around and have some synchronicity between the things they can touch and feel in the real world in VR is incredibly helpful. So the last thing I think I'd say here, I think it's the last thing, is that in VR you have to remember that you can't hide things. You can design a level where normally if you're using like a third-person controller, people can smack into walls and get stuck, and you can very clearly guide their actual interactivity and movement there. In VR, naturally, you're going to find that some people will just walk further than you want them to walk. You might have stopped the collision area or the walls or the nav mesh at a certain point, but someone can still just physically keep walking and maybe go into areas that you don't want them to be in. And typically the solutions to that are like to fade the headset to black, but you just always have to be remembering that you don't have as much control over what people are doing, and you can't, again, move the camera wherever you want it to go, so you have to think more in terms of world building and environmental design than as a filmmaker might, where you just have very key sets that are only facing certain directions and nothing else needs to be built out. That being said, everything I just said, more like guidelines than actual rules. Every single thing I just said, like don't do this, do this. There are experiences that have broken those guidelines and done incredible work. But I would quote Picasso here and say, learn the rules like a pro so you can break them like an artist. It's a good quote. So, diving in now into OpenXR, one plugin to rule them all. What is it? How's it working in Unreal Engine? And what can we do with it now? Right now, it is, first of all, it's an open standard, we'll call it that. That's the right terminology, where the goal of it is to make it so that you don't have to build your experience 9 different times for 9 different devices. It's something that just lets you create one experience, have all the different inputs and mappings and interactions, targeting every different device that it might end up on, and then you can build a Quest version, and a Vive version, and a desktop version, and a mobile version, and on the way, more with augmented reality. You'll notice that most of this is virtual reality. I'm a little bummed that Magic Leap isn't on this list anymore. The first course I made for Unreal Online Learning was like how to build Magic Leap in Unreal Engine 5 or Unreal Engine 4, and now like none of that applies anymore. But the goal really is to just make it platform agnostic. We want to make developers' lives as easy as possible. I say we as though I'm a part of this. I'm not. I'm just reaping the benefits of it. First thing you're going to want to do when you're getting started with OpenXR, especially if you are coming from a background of actually enabling the more platform-specific plugins. You're building something for Oculus, so you enable the Oculus plugin. You're building something for SteamVR, so you enable the SteamVR plugin. By the way, isn't it nice that Unreal Engine 5 doesn't always start up with SteamVR, even if you're not building a VR experience? It was like such a little thing where I was like, thank goodness. But the first thing you're going to need to do is tell whatever runtime you're using to use that one for OpenXR. Otherwise, you're going to build an experience, you're going to launch it, and you're going to say, oh, and it can have different behavior. You might be able to look around, but your controllers won't work. You'll have some kind of unexpected behavior unless you're actually connecting this. And there is some software out there that automates this a little bit more, but the simplest thing to do is just to open up Oculus, Windows Mixed Reality, Steam, and say, hey, this is the device that I'm connecting. Please use this for all OpenXR experiences that I'm running now. Here's some of the plugins that you'll see if you search for OpenXR inside Unreal Engine 5. Mostly for now, you're just going to want the OpenXR plugin. The eye tracking and hand tracking isn't super implemented yet. That's all on the way. And there are other OpenXR plugins on the marketplace that are more tailored to different kinds of devices. So all that being said, I think now would be a good time to try to open up Unreal Engine. And oh, that's the thing I forgot to do. When the computer restarted, and I did not reopen it back up. So actually, while I'm doing this here, I'll show this for a second. Yeah, but the question I get asked all the time is, how do you get started with actually doing any of these things? And the answer is actually to start with the templates. Before you dive in and you say, I've made another experience and I'm trying to make it all work for VR, you actually ideally would start with something that's already perfectly set up for it, and then take that knowledge and bring it into other projects. So we'll start with the collab viewer template, which we're only going to touch on, but this is your out-of-the-box multiplayer solution in Unreal Engine. This is a very easy way to have a host and clients and have everyone join together. It's made for working together on different kinds of projects, usually design. The way you access it is by going into either the architecture or automotive product design and manufacturing sections and grabbing the collab viewer template up there. And here's what it looked like during Simon's lab the other day. We had 15, 20 people at a time all running around together, some in desktop, some in VR, so it's really nice how it supports that kind of multi-platform experience in real time. I'm going to play a little video here while I open up the project. So here's what it looks like as you start to pop into a session, and you see that by default you are actually in not VR mode, so I'm flying and walking and orbiting, but then you can click VR, and as long as you've got your headset connected, you can pop in. Looks like that. Yeah, so as I said, you can teleport right out of the box, move around. You'll notice that whatever direction that is pointing, sorry, that's Unreal Engine hitching it up. Whatever direction you're pointing, that is the direction that you'll actually be pointing after you teleport. And then there's some features here. It's not the full menu of everything inside the collab viewer template, but you can do things like draw, a little bit of tilt brush kind of action here. So here I'm kind of like, oh, I don't know, maybe this should be a window. So you can annotate things. You'll get a little VR keyboard that pops up. And this can all be happening live in a multi-user experience where everyone can see it together. And this is totally extendable. You can add additional functionality to this. But the out-of-the-box stuff is pretty cool, just being able to put everything in X-ray mode to isolate things. And again, doing this all with a group of people, if you're reviewing a project together, is really exciting. There's even Datasmith runtime now, so you can be loading new projects on the fly. Here I am just taking some measurements, we're going to modify this walkway, and we've got to see how long it is right now. Oh, how tall is the building right now? Let's find out. And you'll notice by default it's in meters. Unreal Engine, of course, is in centimeters, but if you do a little scroll down, you can convert everything to imperial there. And over here, the bookmark, you can jump around to different locations that you've preset, so kind of teleported waypoints, as it were. And then the last thing I think I'll show here, or sorry, two more things. One is the section box tool. This is a little bit like, for anyone who's used Revit before, you can have these different boxes that are either including or excluding what is inside of it. So right now I'm deleting whatever's in the middle, then I inverted it, and now we're only seeing what's inside of it. So this is a really useful way to make sure that everyone is focused on the same thing. As I kind of alluded to earlier, I think a lot of times in VR, people feel too much of a need to show everything. You know, if you're building a complete gamer experience, yes, you don't want people seeing nothing. But if you're in like a design review meeting, you know, only show people what they need to see so they don't get hung up on some weird, you know, design byproduct that's off to the side. Hey, Sam, what's up, man? Can I take a picture of you? Great, look at this awesome VR camera I have. I can move it wherever I want and just save that into my folder, and there we are. So very quick rundown of that. I mostly want to focus, though, on the virtual reality template today, which I would say is a little more built out and a little more extendable. So let me see. First of all, this is how you access it. You go into games, and then you can open up virtual reality. Again, it is in games, but I would say that you can use this for anything. I've used it for every kind of project you could imagine. And let's see if I can get it to run. There we go. So here's Unreal Engine opened up. We are in the 5.1 preview right now. And I'll just start by kind of showing you what's going on here. And the first thing I'm going to do is actually make sure that I'm using the original pawn, which I am. And I'm going to make sure that my enhanced input, which is something new, and we'll touch on that, is set up the way that I expect it to. It is. Great. OK, so what I'm going to do now is I'm going to hit VR preview. And you can hear a little bit of the fire burning in the middle. And I'll just give you a little bit of a rundown of what this supports if my VR headset doesn't break the moment that I put it on. OK. So right now you're seeing that I have controllers. We can change that in a second, actually. And I can teleport just by pushing the joystick down. And that will go wherever I want it to. And I can do things like pick up this, and once the shaders load, these will be little yellow balls, and there's some physics going on. We also have a very simple way for creating grabbable objects, which I'll go over. And I can teleport over here. There's a no teleport zone, where you'll notice we're saying, hey, we don't want people over here. And you get a sense of the spatial audio we have. The closer I get to this fire, the louder it is. Now I'll go back for a moment, and I will open up the spectator camera, which actually allows me to be in VR while I fly around with my WASD keys. And fun fact, the spectator camera actually works even if you don't have a VR headset attached. So it can be kind of a useful way to just zoom around your level. Although something I recently learned, and I just want to share it with you, is even if you don't have something like a spectator camera in your scene and you want to fly around, the semicolon on the keyboard or the console command toggle debug camera will actually let you fly around any scene at all, which is pretty cool. So that's a very, very quick overview of what we get out of the box. And what we can do now is show a very, very quick preview of what the hands look like. So this literally just released with Preview 2, but now you have some nice inputs there for if you want to use hands as part of your project. And we'll dive into the blueprints a little more for that setup. So to go over a little bit of what you get out of the box, first of all, something amazing about this template that blew my mind the first time I opened it is as long as you have Android set up, you can build to Quest and to Windows immediately. I think Linux is almost there as well, which is pretty cool. So it's kind of nice that you don't need to do a whole bunch of different configurations for Windows and for a mobile headset. It can build exactly the same project, exactly the same starter map, and work great on both a totally mobile standalone platform and a desktop one. So how is it set up? Now we're moving a little bit more into the territory of what if this is something that you actually want to implement in a project that you've already created. Again, I would say start with the templates, but let's talk a bit about what you're going to be doing. First of all, as we kind of alluded to with OpenXR, you can use a variety of different headsets. There are different considerations if you're targeting desktop versus mobile. You can have everything scaled down so that you say mobile's the baseline, and then anything desktop is still going to kind of be running at mobile settings, or you can have different branches in your blueprints that might target certain kinds of settings based on what the platform is that is detected. You can do that manually or automatically. I also want to mention that something that's happening more and more is a move toward the ability to pixel stream, cloud stream. I mentioned my company earlier, where you can use things like NVIDIA Cloud XR or AirLink or Virtual Desktop or Vive Business Streaming to use a standalone headset like the Quest, totally wirelessly, but get the fidelity of something that's actually running off a much more powerful computer, either one you have locally or one in the cloud. And so I'm finding more and more these days that I like to crank up my VR settings, make things as good looking as possible, and then run it on hardware that can handle it. Only tricky thing there is you need to make sure you have a strong enough internet connection to handle the latency of going back and forth, and also streaming a high enough resolution setting. But it essentially becomes like a Netflix Bandersnatch kind of level of what the data signal is like, because you need to tell that computer where your head is, what your hands are doing, what buttons you're pressing, and then it needs to send you back in milliseconds exactly the signal that you should be seeing. That being said, you might think like, that's definitely gonna make you sick. Not necessarily. I've been very impressed. There's a lot of predictive algorithms that help make sure that you are going to feel comfortable in the experience. And if you turn your head really fast, there's certain assumptions about the way physics works that allows some predictions to know where you're going to be in a moment. OpenXR again, one-stop shop for input. You'll also see as I open up the new enhanced input settings that it's very, very straightforward now to make these modular UAsset files. You remember before with input, you'd have like a little, basically a text or an ini file that had everything listed there. Now you have these assets that are much easier to share and bring across projects that are targeting different devices. And then, yes, just a little reminder, OpenXR with Lumen Nanite, it's there, not super stable quite yet. So when you are targeting Quest, one thing you'll want to set up is in your VR settings, in the project settings, ideally you use something like foveation. Foveation is what allows you to render the middle of your view at a much higher resolution, higher quality than what's around. I think the human eye only actually is ever looking at something like 3 or 6 degrees of its view. So being able to get closer to only rendering that saves a lot of processing power, especially when you're running from a mobile GPU. Being able to have everything else be rendered at a lower resolution or blurry or whatever is easier for a device to render is pretty great. And you'll notice there's low, medium, high. There's a dynamic foveation level. And now as we move toward more headsets that have eye tracking, that also helps with knowing exactly where you're looking and how to foveate that rendering. Typically with a device that does not have eye tracking, it's just going to be the center that has a higher resolution and everything else around it is going to be more blurry. Some other things you want to make sure are on: instant stereo, mobile multi-view. Be careful about enabling mobile HDR. It says mobile HDR. What it really means is, do you need your post-process volume settings to be working? And again, some post-process volume settings don't work with VR at all, especially on a mobile device. But if you are going to be enabling mobile HDR, that's probably because you have an experience where you've done the color calibration just so. You're using lookup tables, or you want the bloom to be a certain way. You're doing a theatrical experience, and you want all this nice bloom to come off of your lights. It's incredibly expensive. So just be aware that the moment you hit that checkbox for mobile HDR, you're cutting your frame rate in half, basically. Also, round robin occlusion, just another checkbox I actually would recommend hitting. I don't know why I took a screenshot where it's off, but it gives you basically 1 extra frame of latency, but then actually has pretty significant render savings. On Android, I'm not going to go through the whole process of actually downloading and installing Android. There's great documentation on that, but once you do have it installed, there's just some basic settings you want to do for what the name of your project is. You usually do company name, whatever your project name is, and then you can make sure that you're using the right SDK versions, and that's all down there in the Android plugin setup. You might also see some warnings that say, like, this project is not set up for Android yet. Would you like it to be set up? Yes. So they do try to walk you through this in a fairly straightforward way. Over in the SDK settings, this could be populated automatically, but you will have to tell Unreal Engine where all of those paths are. And I guess I should have also been very clear. The reason why we're talking about Android is because most VR standalone devices right now run on Android. When Apple comes out with their headset this year, in 5 years, in 20 years, whenever it happens, probably will not run on Android, but right now that's the state of the industry. Forward rendering. So this is right out of the box, I can tell you, like, this is the thing that is going to make VR much, much more performant for you. It also means you cannot do Lumen and Nanite. Forward rendering allows you to render much, much faster. It works great if you are baking a lot of your lighting, if you are going to have a scene that is very optimized. If you're going to have a lot of mobile lights, if you have things that are moving around, then you actually might get better performance with deferred rendering, which is what happens if you just uncheck the forward shading checkbox. But it's going to be a much heavier scene, and would not recommend trying to do that on a standalone headset. Another nice thing about forward rendering is that you can use multi-sample anti-aliasing, which is very, very sharp. Looks good in VR. I wouldn't recommend using it with metahumans. I find metahumans look more uncanny valley with it. Just my personal opinion. I actually try to use deferred rendering with metahumans in VR if I can, and I usually don't put them inside a standalone VR headset. Some post-process settings you might want to be aware of. First of all, again, they're expensive, so even at the engine level, recommend turning them off if you can, or overriding them in the post-process volume. Quick reminder about the post-process volume. I know a lot of people, they see the checkboxes, and they think the checkboxes mean you are turning on settings. What it actually means is you're overriding settings. You have your post-process settings in your INI file that shows up in your project settings. Those are all on by default. Any checkboxes you have there are just on. Then you override those with your post-process volume. So if something is off, you can override it by saying it's on. If something is on, you can override it and say, no, for this particular volume, I don't want bloom on. Another thing you'll want to be thinking about is that cameras can do another level of overriding. And that can be your VR camera, it can be something more cinematic, but that's just another level of overriding the overrides of project settings, post-process volume, something else. So some basic settings here. Set your screen space ambient occlusion lower off, it's expensive. Set your bloom lower off, it's expensive. And I just have to say, I think convolution bloom looks chef's kiss, so good in VR, but it is very expensive. Screen space reflections, if you can. I mean, if you have something that's very, very blurry, I think they're okay, but for the most part, particularly in VR, I find them incredibly distracting. And in deferred rendering in particular, they actually have something like really wonky going on with them. Then they don't really work with forward rendering at all. And then also with reflections, I'd say planar reflections, I have a slide on that in a moment, they look great, but they are very expensive. But they are the best mirror quality setup in VR if you want to have good-looking reflections outside of course, ray tracing and Lumen, which you can do in VR. It's just a factor of 5, more expensive than anything we're discussing here. Lens flare doesn't look good in VR. Motion blur doesn't look good in VR. Don't put dirt on people's lenses the way you would with like a little free cam war cinematography thing. It's going to make people feel very wrong, like their eye is about to die. So be careful. Here's the setup for planar reflections for anyone who wants to play with that. It's just one checkbox. It'll recompile all your shaders. And you just have to be careful because it's expensive. And sometimes when you're using a render target like the spectator camera does, which we'll go over more shortly, it can look a little bit funky. But target hardware, this is a setting that is just a very, very quick way to, even in an existing project, to start to make it be a little more suited for VR. If you just go ahead in your project settings and you change it to mobile and scalable, it's going to be like, oh, do you want to change these 30 project settings? And you can say yes. And now all of a sudden your project is much more optimized for VR. Also, this is going to be going away soon, but it's not gone yet, so I do want to mention it. If you enable the Oculus VR plugin, which normally you wouldn't do if you're using OpenXR, there's a great little tool in here that you can use for any VR headset. It doesn't have to be an Oculus, Meta, Facebook, whatever headset. And you can launch what's called the Oculus Performance window, and it will actually flag things that it sees in your project that might be costing you frames. Just a very nice kind of like, oh, hey, you're on mobile and you've got a bunch of movable lights casting shadow. Maybe don't do that. And it's just a good little, I'd call it like a stupid check. Even if you've been building VR experiences for years like I have, I'll still pop into this every so often and say, oh yeah, of course. I made everything glass when I could have just made all those windows blank, and on a mobile VR headset, it's definitely worth the cost savings to make glass nothing, for one particular example. VR mode I want to touch on as well. This was something I got super excited about when it was introduced maybe 5 or 6 years ago. It was called the VR editor then. To access it, you do actually need to go back and enable Oculus VR, Steam VR, etc. It's coming to OpenXR, But what it allows you to do is take any scene that you have running, doesn't even have to be a VR scene, as long as you have those plugins enabled, and it lets you explore that scene. You can fly around, you can move things around. There's two different modes. This first one is basically like the VR editor mode that lets you pull up your content windows, you can drag materials onto things, you can simulate physics, you can have a cute little flashlight that you can go around your scene with, and especially if you start playing with something like Lumen and Nanite, in 5.1. I'd recommend actually starting there. I find that it actually runs much smoother than trying to do something like VR Preview or a build, probably based on the way that it handles resolution. And then that's just how you set it up a little bit. It's a little bit of what it looks like. It's great to paint things like trees and do your landscaping because you just feel like a god who's like mountain, tree, and you just get to set everything up that way. You can move cameras around any kind of objects you want. And you can also make it so that if you're really going hardcore into the VR editor, you can make it so that every time you put on your headset, it's like, all right, we're doing the editor, but now we're in VR. It just does it automatically. And then, this is newer, this is the virtual scouting tools that come inside the virtual production template. This gives you this wonderful array of cameras and tripods, and you can create dolly tracks and set up markers for A camera and B camera. And it's a very cool system for thinking about virtual production and just feeling like you're on site. So it's a pretty easy template to even migrate over to an existing project. And now you're walking through your environment and setting up all of your shots. And again, the final project might have nothing to do with VR, but it is pretty cool to be virtually scouting a location if you're just setting up some cool videos. Okay, VR Pawn extensions. Let's see how we're doing on time, pretty good. So I'd like to show you guys a little bit of how we can make very loud fire, how we can add a few features to the setup that's already inside of the template that I would just call them, extensions. It's taking what's there and maybe going a little bit further into options, into scalability, into different levels of comfort. So the first one I have here is dash teleportation, which is instead of blinking from one spot to another, it actually kind of lerps you from one location to another. And I use the timeline node, which is basically like a little sequencer that plays everything over a second and then brings you there. We'll look at that in a second, but actually the first thing I want to show you guys, I should have moved the slide earlier, is a dampener to dampen your spectator camera. Because I find that, and let me just demonstrate this, and feel free to close your eyes if you don't want to see this, that if you just watch someone inside VR, like me here, it can be a little bit nauseating to just be like, oh my God. Like I might be having a great time. It's kind of like someone who's a crazy driver in a car and they're having fun swerving all over the road and you're a passenger who's about to throw up. So first thing I'd like to show you is how can we make this a little bit less wonky? And it's actually not that hard. So let's go ahead and open up again, and we are literally just in the sample scene that anyone will see if you come into this project. And we're going to open up BP VR Spectator. So edit. And in here, we'll just go through a very quick rundown of some of the things happening in here. We say, if it's a mobile device, we can't do a spectator camera, so don't worry about it. Initialize your input, because you got to make sure you can click things. The level blueprint, just a reminder, is the only blueprint where you can just put in inputs for things and they're going to work. Otherwise, you need to say, hey, please do this. Find the player controller and make sure that it is enabled for them. This is the new enhanced input local system, so you do this also. You do a mapping context, and then you say, hey, I want to use these keyboard presses in this way. We'll dive more into that in a moment. But we go through this, we say, okay, is the spectator camera enabled? Great, then let's jump over to here where we enable the spectator camera. You don't necessarily need to know what every single node is doing. I often say blueprints, it's a little bit like driving a car, to go back to the earlier analogy. You want to know enough about your car to be able to take care of it, but you don't necessarily need to know how every gear and axon and piston works inside of it to get it to do what you need it to do. So we enable the VR spectator. There's a toggle for making it go on and off. And you'll notice the input nodes here. Again, enhanced input, kind of a different setup, triggered, started, ongoing, canceled. And what we basically want to do is we want to find what's happening on event tick, which of course is every single frame. And so right now it's changing the field of view as needed, because we can do that with our mouse wheel. And right now there's two modes. There's a fly mode, and a first-person mode. And basically, the first-person mode, as it is just going to match what you see as a VR player, but that's the spectator view. And again, I think it's a little bit nauseating to do that. So let's see if we can dampen that. And so what I can do is we can say, OK, if we're in the first-person mode, then I'm going to create a new custom event that is going to actually handle this dampening. So we're going to come down here. I'm going to type in custom event. And I'm going to call this dampen VR camera view or something like that. And then just so I don't forget, I'm just going to go back up here and remind myself that that's what I want this to connect to, even though it's not doing anything yet. So if we're just in fly mode, if we're going around with the spectator cam however we want, no problem at all. If we want to jump into here, then it's going to pop down here. So what we're going to do at this point is we're actually going to go and we're going to find, or actually we can just right-click here, and we're going to find an interpolation node. So an interpolation node, a little bit back to like lerping and trying to smooth something over time, there's different first letter prefixes depending on what you're trying to do. So you can do F for a float, you do V for a vector, and I'm just going to do a transform, so T interp 2. And so this is kind of a magic node. When I first was trying to set up my camera dampening, I had like 100 nodes here, and I'm like, oh, it was a lot of lerping. And then I found that this one really does exactly what you want, because you are going to say, hey, here's where this thing is now. Hey, here's where I want it to get to, and it's going to do it kind of at the speed that you want it to go at. Oh, don't autosave. So we are going to go and set an actor transform. Actually, we don't have to do actor transform. We can do the actual camera one right now. So we can do set world transform for our actual camera here. I'm trying to do it for the actor, not the component. There we go. And now, target self, that's all fine. This is going to plug into here because that's going to be the new location. And now we just need to know, where is it getting to, how much time has passed, and what speed do we want to do it at. At 0, you're going to be doing it immediately. There's a lot of things in Unreal Engine where 0 means like almost ignore it, like just skip right to it. But then as soon as I bring this to something like 0.1, it's going to be very, very, very slow. Versus then I go to something like 10, and it's going to be much faster. So we'll see that in a moment. I'll leave it at something like 0.5 for now, so we can see it. For delta time, basically we just want to be getting the equivalent of the event tick up here. So just to grab that real quick, get delta time, or it's delta time or world delta seconds. It might be world delta seconds. How much time has changed? Remember old math classes, delta means like a change over time. And then current, we're going to say, OK, what is the current transform of our actor? Oops, not the comment box. Live demos are fun, pressing wrong buttons and everything. So we're just going to get actor transform for self. And then the target is going to be wherever the camera is. So we're just always, in a lazy kind of way, trying to keep up with where the actual VR camera is. So we're just going to get the player pawn, 0, and we're going to get their actor transform. Actually, you know what? Instead of the player pawn, because that won't necessarily be where the camera's facing, we're actually going to do a different one here. We're going to get player camera manager. That'll actually show you where the actual camera is, and then we can connect that into there. Now, do bear in mind that because we're doing the entire transform, if you've got a different scale, that can start to get kind of messy. You could also do, there's a node for set location, set rotation that leaves out scale entirely. But this is kind of the really simple way to just go ahead and dampen the camera. Something like that. OK. So again, just to review, up here, we're saying, hey, on event tick every single frame, let's check to see if we're in fly mode or first-person mode. And if we're in first-person mode, let's go ahead and dampen the VR camera view every single frame, and so this is firing every single frame. We're trying to set the current actor transform of the VR spectator blueprint. We're finding where it is right now, and then we're trying to very slowly, at a speed of 0.5 at the moment, and we could, of course, promote this to a variable, public variable even, once we compile. Public. We're just going to try to get it to get close to whatever the VR player camera is doing. So save all, come out of there, and right now, we could actually set up a button for toggling between these, but I'll just say instead of fly mode, down here we're going to do first person mode. So let's see if that works. Go ahead and hit play. And I'm looking around, and you see it's all wobbly, and oh no, stop it, Alex. And then I go into this mode, and it is first person. And what's actually very interesting is right now, I'm actually not even seeing this in VR. So something funky is happening, because I don't see the experience. All right, shall we resume? Great. I like that attitude. So let it be known that I did everything right at the end of last session, and the VR headset was just freaking out. This is a slightly more robust version of the VR spectator template that we were just looking at. I'll walk you through a little bit of how everything is happening, but those key functions that we did together, that's at the bottom there. We're setting the actor transform. We're using the transform interpolate to. We're getting the current location of the spectator camera, and then where the player camera manager is, and then trying to basically connect them. And so let's just see what that looks like in action, because it is going to guide what we're doing moving forward here. I'm going to talk about that one in a second. So here's our scene, and I also had a 5.1 preview 1 version of the project open before, so that's why we didn't see hands. Now we should see hands. So you'll notice, by the way, I'm also going to launch a standalone game here. The reason I was playing more in standalone while you were all gone is because there is a feature where you can change your size in VR, and right now it works totally fine in a build. In the editor, it tends to not behave correctly, so if you do a standalone game, it's treated almost like a build, and then the only thing you want to make sure you do is in your, not project settings, in your editor preferences, you'll want to make sure that you launch with the launch parameter -VR. So that's just like you would do a launch parameter for a built version. That will make this work correctly. So let me show you real quick what's going on with the spectator camera. I got to pop back into VR. You'll notice if a headset isn't detected, that's what it will go to. But I think I'm still in it. Here we go. Okay. So I'm here. You'll notice I've got hands now. So this is my fully decked out pawn that has all sorts of expansions from where we start in the template. So we'll walk through a bunch of those before we get to some fun, very experimental Luminanite stuff at the end. So let me toggle over. Actually, it's doing it already. So I want you guys to notice that if I do this, it's not nearly as shaky as if yeah, there we go. So that's much shakier. And then what we can do is we go to the spectator camera. So here's the spectator camera. And then I can go over to match what I'm doing. And now even if I shake my head a bunch, it's dampening it. So it's a much smoother view. And now I'm much less likely to make all of you sick. I mean, you know, and I would say there's a sweet spot, because if you do too much dampening, it almost feels like you're on a swing or something. So I'd almost call this a little bit too much to the right, so to speak. But it's a lot better, I think, than just getting the super shaky view that you would otherwise get. Someone was asking during the break about when you have maybe not the best PC, and you do want to provide a spectator cam that isn't going to make people sick. And I have a good answer for that, because I've been in exactly that situation, carrying around a subpar laptop to give VR demos on. And what I've tended to do in that situation is I will go into the spectator camera right here, and I'll go ahead and I will, you know, go to my scene capture with a texture target. I'll crank this up to a very high resolution. I'll make sure that I'm rendering at, you know, top quality for the capture source. I'll go into the post-process volume and crank up all the quality settings there. So that all looks great. But then I'll go onto the VR side, and in the VR pawn, in the camera, I'll crank everything down. So that way I'm getting a good frame rate, and I can be in VR for a while without getting sick, but I don't have all the bells and whistles of bloom and other high-quality features on in VR for me. I'm tailoring the quality of the experience for the majority of the people who are watching it, depending on the presentation. Because as I said at the beginning, sometimes you just will get people who do not want to be in VR. They're okay with watching someone be in VR. And again, I've done a lot of theaters in my time, so it's a lot of like, Alex, can you please lean forward? Okay, I'll lean forward. And they just want to see like how the view changes. And you want that experience to work well for them as a spectator. So let's go ahead real quick and open up and just take a little bit of a look at some of the additional settings we have. So this is where we kind of started. We're firing that event, as we said, we're connecting all this. But I also have another feature in here that I wanted to add in, because one thing that's a little bit of an issue with having it in the simplified setup is if you want to toggle between the flying version of the spectator camera and the version that matches, when you press tab to go back into the flying version, it is actually still going to be matching where your head was, because you've physically moved over the spectator camera to where the head is. So what I'm doing here, I'm saying, okay, let's flip-flop when we press the M key. I am not using the enhanced input here. Very bad to just like say we're going to press the M key. But we can say that first, we're going to be in the first-person mode. And then before we start doing what we're going to do, I'm grabbing the transform. I'm saying, where is the spectator cam right now? Let's save that. We're going to save that, so then when we are done going through all the wild, wonky world of being inside the VR player's head, we can snap back to that other location that the transform was at before. So we're saying get actor transform, set that as a transform variable for last free transform. I then just do a little debug that says we're now matching the player cam. And then, this is a little bit more advanced, but I'll walk you through it anyway. Then I'm actually going to cast into the VR pawn, because there's a little bit of a problem when you do a dampened camera, where, as you might have noticed, there's a headset now. We do just by default, you could turn it off, but there's a physical static mesh of a headset. And if you're dampening the spectator camera, you keep bumping into that headset. So the little thing I'm doing here is actually popping over to the spectator visibility, and I'm saying, hey, are we going to be bumping into that thing? Yes, then let's go ahead and hide the HMD, so that's not in the way. And similarly, I'm doing something over here where for the camera mesh, I'm making it so that it is only being seen in the scene capture. The scene capture is what's happening over here. So that way, the VR player doesn't have the camera constantly bumping into them in the scenario where the camera is actually following them directly. So that's a little bit of an extension on the extension we already did. And then down here, just a very simple flip-flop toggle. Sometimes I like to actually assign caps locks, especially if I can see the light, to something where I actually want to see if it's on and off. And in this case, we're doing a back and forth between the fly spectator mode and the first-person spectator mode. But everything else, I think, for the spectator side looks the same. We're just saying up here, if we are, oh, you know what? I think, yeah, okay, here we go. So out of the first person, we come over here, and we match the VR camera. I think actually the problem with what happened before is I think we were actually going through here. And so this is actually saying, hey, let's match the camera directly. It's not doing any kind of dampening, right? So that way, if we bypass that entirely and just go right to matching the camera with our interpolation node, then that's a lot smoother. So there we go. That's the spectator camera. One other thing I want to touch on that came up during the break is controllers. So you'll notice right now in my special extension pond, I've got a bunch of assets in here that I've called _ext for extension. And so in that pond right now, I have the hand. The hand comes by default in 5.1. You can see all sorts of fun hands. And if you want to also have the controller, or have the controller and not the hand, let's say you don't want the hand, you could go ahead and just set the visibility off for the hand. Or sorry, nope, not that one. We could go down to, I didn't actually check it. Yeah, visible. I thought I typed that in. So you would uncheck visible so you don't see the hand. And then up here in motion controller right and motion controller left, not the aim versions, because that's just for something with the menu I'll show you in a moment. You'd actually go down to motion controller, motion source, right, left, make sure those are matching, they should. And then above that, display device model. So by default now, that is unchecked. In 5.1, it's unchecked. In 5.0 and previous, it was checked. And so you can say that you just want to let OpenXR take care of it. You can say, oh, I bet OpenXR is going to know what kind of device I'm on. And I'd say maybe 70% of the time will show you the correct controllers. If it doesn't, or if you want to be more discreet in how you're setting it up, you could go ahead and say custom, and then you could actually tell it exactly which model to use. You know, we got Pico Neo in here, Samsung Odyssey, all sorts of different controllers. You would just basically type in controller, and it'll show you a bunch of different headset controllers. And you know, we can do it directly in here, or you could set up something like maybe a select or a switch parameter that is getting the HMD data, a little trickier with SteamVR, but then you can feed all that out and start to automate that in kind of your own little custom XR solution. So for the moment, I've just got both on at the same time because I think it's kind of interesting to see the hand holding the controller. I did actually have to rotate the hand a little bit in order to fit a little nicer. So I'll just point out I've got 17 degrees and negative 17 degrees on the y-axis to have the hand and the controller on at the same time and looking okay. Okay, before we go back into the presentation, one thing I wanted to point out is just a little bit of advice for desktop versus mobile. This is a little architecture project I tend to teach with, and I have 3 maps of this project, and each map is targeting a different configuration. One is a nice, high-quality computer that can render things fast. In this case, you can try to make it look like a good VR experience, and there's some things I have on here that I then start to turn off as I go down into lower-end hardware. So I thought it might be nice to just walk through that a little bit. A couple things I want to draw your attention to. The water. I've got some nice-looking water here with some reflections. I have got, oh, actually, I'm sorry. This is the middle version. Let me start at the high version. I forgot that I reopened up the project. So we're going to see the better version first. And then we'll kind of step down. So here we go. So you know we got like all this nice bloom on the water. Look at the lights here. We got some nice convolution bloom. I'm going to turn off the grid. I can never find the grid. That's just G, thank you. Yeah, good shortcut. I've got some plants. I've got a bunch of trees everywhere. I've got a movable light, and I've got some higher quality furniture in here where I've set up. I do have some baked lighting in there, but I also have some movable lights. So if we go ahead, for example, and look at our sun, this is set to be entirely movable. And the reason for that is I have a little sun study that actually will physically change the time of day. And I think we can even see that if I just hit play and just go into like the spectator view. So if I press, I think it's K on the keyboard, we can see the shadows changing. And we could actually see the sunset as it goes into night. Right? And so that's kind of what you can do on the highest end. I'd like to do that where we can actually see the camera. Hold on real quick. Let me just, and you'll notice I'm not even connecting to the camera right now, or the VR headset. And I've got some blockage there, but let me press K real quick. There we go. So there's the sun going down. And you got some nice bloom and light shafts going through there. So this is kind of like the higher end version of what you could do. My windows are actually glass. We've got some reflections on them. And that's all great for a higher end configuration. Also, the amount of foliage is all going to run fine, 90 frames per second on a machine like this. So then we step down a level, and now we go desktop low. And then we start to do things like decrease the foliage. Now we are baking all the lighting, and the sun, though, the sun you'll notice is set to stationary. So I'm not going to go over how lighting works. I'm sure a lot of you have already done this kind of stuff before. But a stationary light, of course, is something where you can change the intensity and the color even after baking. And so on a lower end VR configuration, this is where I might do kind of a fake sun study. So I'll do exactly what I just did. I'll go ahead and hit play, go over to my spectator camera, and you'll notice now that if I were to go and press K, we're going to see everything get dark, but we're not actually seeing the sunset. So literally all we're doing in this sun study is turning down the intensity. So again, no movable lights, everything's baked, but by having one stationary light, we can kind of simulate the idea of a sun study while targeting lower end hardware. By this point, I've already removed the glass because I was hitting some frame rate issues in there, and we'll go over some of the things like geometry merging that I did to also help this render faster. But yes, there's no glass now. Everything that would be glass is just clear. Translucency, of course, is very, very expensive in any context, but VR in particular. And I've simplified the water a little bit, and I'm just using a standard, very light bloom, no longer convolution bloom, even though it looks very good. Next map. So this one is targeting Quest. And in this one, you'll notice that it's much, much, much simpler, right? And this actually is not representing exactly what it would look like on Quest. There's actually an Android mode we could enable. I'm not going to do it right now because it will take forever to recompile, but I could click Android Vulkan here, and that will give me a closer sense of what it's going to look like. But here, can't really afford any foliage, so I'm using an HDRI. My lights are all baked. I'm not even doing anything stationary. And for the water, what I've done here is I've still left the panning texture. All I've done is I've changed the material. I think, in fact, I just did a material override. I think I just went into here. No, I didn't do it here, but basically it's this. Like this was set to translucent, and I went ahead and just made it opaque. So just by doing that, you can see the shader instructions in the upper left. I think I cut it down by like a factor of 5. It was like 3,000 shader instructions, and now it's like 855. So you can still get a little bit of the same effect, but now you're trying to make it run very smooth on a lower end device. And this isn't going to be the most beautiful scene in the world, but this is also targeted toward like what an indie developer can do when you're cranking out models really fast. This was a fast way within a couple hours to be able to target 3 different platforms without having to optimize 1,000 things. And speaking of that kind of optimization, we have some optimization view modes over here, which are really useful. So like shader complexity, you want green. Like in this case, I'm letting the fire be kind of a special snowflake in the middle that we can all have our attention drawn to because it does look a little bit more robust than everything else. We can look at things like our light complexity, which is nothing here because everything is totally baked. We can also look at our level of detail coloration, which is useful because we can start to see some of the higher geometry things like the rocks are actually getting different levels of detail there. I've also removed some things like curtains, which even at a lower level of detail were becoming very, very complicated. There's no need to have LODs on things like these walls because they're already very simple geometry. And of course, if you start to go to something like Lumen and Nanite, not compatible at all with mobile devices, then that's pixel level LOD, and you don't have to worry about that at all. Okay, so just wanted to fly through some of those features real quick. We've looked at our updated spectator camera, and now I'd like to go through a few of these extensions I've done to the default VR pawn, just to give you a sense of how we can add more options. So we'll remember our old friend, the VR dash teleport. So the idea here, once again, is that blinking from one location to another, sometimes that's fine, but if you want to feel a little bit more like you're getting the sequence of moving from one spot to another while still maintaining a certain level of comfortability, you can do the teleport but actually have that very consistent movement from point A to point B. And for me, like I'd prefer that kind of teleport over a blink one because I still have context. As a former architect, still kind of architect, I'm always thinking about the progression through spaces. And I love the sense of compression and release. I used to commute into Grand Central every day, and to be like on a tight, tight train for an hour and a half and then to open up into that space is a really incredible feeling. And the contrast is important, and you lose all that when you're doing things like teleporting. So here's the little blueprint. We'll look at all this stuff together, but that's what we're going to have set up. VR flying is another one here that we're going to take a look at. So instead of teleportation, if you got the sea legs for it, very cool to just fly around the scene wherever you want to go. And the blueprint is not that complicated to set up. You basically need 2 axes. One axis is going to be forward and back. One is for strafing. And you're just adding really that one out-of-the-box component, add movement input, add a certain vector, add a certain amount. We've got move speed in there. And actually, I'm going to show you the little node we have here is axis greater than dead zone. That's intended to be so you're not accidentally, touching the joystick and it's like moving and you're like, oh God, I didn't actually plan on moving, and you feel sick. So you often will have a dead zone, and you'll do this with like Xbox games as well, where you're saying you want people to like really be putting some intention into how they are making the player move. And with the new enhanced input system, you don't actually need to set up dead zones anymore. That is part of the input system. So I'll show you exactly where that is now. And if I'm being totally honest, I only discovered it like an hour before my talk. So I was like, great, that can make the blueprint even simpler. And here's a little bit what flying can look like. So, and obviously we have the spectator cam following this too because of the way it's moving. VR scale adjustment. So this is what I was just mentioning, that this is only going to work in editor if you do standalone. Otherwise, if you're in VR preview mode, you're just going to see the controllers scaling and not anything else. But the magic of VR, of course, is really having a sense of scale. This is something that won't look any different if you're not in VR. But if you are in VR, you can go from that human scale level to an ant level to I'm a god and this is my dollhouse. And there's a lot of contexts where that's really useful. There's a game my kids love to play on Quest called Half Plus Half, and there's like a hide and seek experience where one of you is a giant and the other one is very tiny, and there's this little like playground to go hide in. And games like that really only work properly in VR because the 2D version isn't as nearly compelling in that way. So yeah, we're gonna look at all these blueprints together and how they're set up. And then we'll go into things like creating grabbable objects. So let's pause here. And by pause, I mean let's actually open up the template. And let's also just very quickly see all of these things in action. So I'm going to go play, save everything. What did I change? I always get nervous when I'm unexpectedly being told to save something. Like, did I delete something? Why is it new? All right, so as we saw, I've got my hands here, doing my thing, click, click, click. And on my left hand right now, I'm moving my joystick, and that's letting me fly. And the flying is happening based on wherever I'm looking. Sometimes you might want to fly in the direction of your controller. Some people prefer that. I prefer for forward to always be the vector in the direction that I'm looking. That's my personal preference. Over here, with the right joystick, I have it so when I push up, I'm getting bigger, 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 and it might not be obvious on the screen except for my shadows and the fact that I can now be like, oh, look how big my hands are compared to this little ball. And you can even see from like a gravity perspective, everything feels a little bit different when you're a giant. I've also set up a little toggle on here where if you just very quickly want to snap back to human scale, you just click the joystick and you just snap back to being the size of a regular human. And that's pretty simple as well. One thing I haven't shown you yet that I just want to pull up here real quick is the menu, and that can be accessed with the B button and the Y button. And these are the default buttons, but I'll also show you how we can add some additional ones to this. Finally, I think this is only true as of 5.1, you can actually do an OpenXR-based reset of your orientation that wasn't working before. So I can be facing some weird direction and then do that, and now this is my new forward direction, and that works with just about any headset, which is really nice. The restart restarts the whole level, and the real life is actually going to quit. One other thing I've got on here is the teleportation. So by default, teleportation, and I have no idea what direction I'm facing now. Hey guys, the teleportation by default is done by pushing the joystick forward, but because I've now mapped that to changing the scale of myself, and I've added some haptic feedback to make that feel more, powerful, the fact that I'm actually changing size, which is no small accomplishment. I've now made it so that the A button is my teleport button, and you'll notice that I've got two things on here. We're doing a fade to black, and we're doing that dash teleport. So in the default option, there's no blink, and there is no the dash system of moving. And as I said, I do prefer this. And if I can handle flying around, that to me is the most free and wonderful version because it's so different from what's possible in the real world. You'll also notice my body is a gun, and I forgot that one thing I was playing with was, I'll show you this now. Oh, and by the way, the whole time I was doing that, I meant to be in the spectator cam, so sorry for not being in a smoother motion mode, but that's what I look like right now. The reason why I was fiddling around with that is if we go over and we open up my pawn, there's a few things I'll point out about changes I've made to my pawn, and I keep thinking it's in my scene. It's not. It is right here, vrpawn_extension. And you'll notice that over here, this looks a little different now. The first thing I did is if you want to be able to easily fly or walk around. I didn't show you walking around, but I can just do like smooth locomotion. I'll show you in a second. But the way you can do that is, by default, you have a VR pawn. I don't know why I'm wearing this like a hat now. I can take it off. We can actually go ahead and convert our parent class to be a character. And as soon as you make it a character, it does a few things. It adds a capsule component at the top that becomes the new parent. It also gives you a character movement component, which has all sorts of fun features. You can add in swimming at that point, flying, walking, swimming, jumping, if that's going to be part of your experience. And that all pretty much is there out of the box with minimal implementation. The way you do that, by the way, is you go to your class settings and you just change the parent class. By default, the parent class is a pawn, and then you can change it to character, and then it makes those adjustments, and pretty much everything else still works. You are going to have some problems with snap turning because of the way rotation works with the character component, but we'll touch on ways to fix that. But let's look at some of the blueprints we have going on in our updated version. You'll notice I'm color coding my comment boxes for anything that I've changed. So let's start on the left. First of all is teleport. So you'll notice that I decoupled this from the joystick. So this was the input action that was already in there. I just moved it off to the side, and I made a different one here. And we don't need to know anything about how teleport's working, just that we want a button to trigger it. So this might be a good spot to do a very brief introduction to the new enhanced input system, because as you saw with the spectator camera, I just had like press the M key and then make a thing happen. That's not so bad if you know that there's going to be a keyboard involved, but as soon as you want to map something to controller buttons and you know multiple headsets are going to be using your experience, this is where something like the new enhanced input system becomes really useful. So if I double click on this, I'm going to see something that doesn't seem like it has a lot. And you're thinking like, oh, wait, where's the part where you actually say what button it is? All we have here, and IA is input action, move teleport button. All we have here that's important is the description and the value type. And the bool, of course, it's a Boolean. We're saying it can either be true or false. We have a few other options in here too. It was mapped to be an axis 1D float because it was saying if you push the joystick forward enough, that's going to act as the trigger. 2D vector 2 would be X and Y, like you're moving the joystick all around. And then a 3 vector, of course, is more complicated than that. So in this case, we just have a bool. But then you say, OK, where are we actually triggering what's going to happen? So with the enhanced input system, which is a bit of a mouthful, and I'm still getting used to it, this is the top level. You have a file called a player mappable input configuration. So we'll open this up. And everything in here is exactly as it came in the OpenXR template. Something for hands, the weapons, the menu. And again, I'm not going to give a whole class on this because I'm still learning it myself. But as you can see, these are different contexts for what you want your input to be doing. And it's all UAsset files, so it's very easy to migrate over to other projects. And you see menu, weapon, and then the only thing I started to change is the default up here. So I have an _ext for what I was changing. So I open this up and I look at the mappings. And every one of those input actions is listed here. And this starts to look a little more like the input that you're used to in the editor, where you have all of those input actions, and they're all basically saying, I'm an axis, I'm a bool, I'm a 2D vector. And then you just list here what's going to be using that. And this is the same way it's always been. So y-axis, x-axis, left hand, right hand, different kinds of controllers. And you'll notice that I added some down here for fly. And there is my move teleport button. And if anyone has an eagle eye, you're going to say, Alex, you're very lazy, because you'll notice I didn't actually set it up for OpenXR. I was in a hurry, and I'm like, we're just going to do it for Oculus. If I was doing this correctly, I would keep adding, the equivalent of the A button for all the other headsets as well. So both of these, the reset scale and the teleport button, are Booleans, and it's just one thing there. And then all the way back over here, that's what's happening here. So we're saying whatever that's mapped to, we can have something happen when it's triggered, when it started, ongoing, canceled, completed. We have all these options now for doing a thing based on what's happening with that button. Oh, and I wanted to show you the thing about dead zones. So let's open up really quick, and then we'll walk through this in more detail. Something like walking, flying, right? So you'll notice I don't have anything here asking for a dead zone. This blueprint is even simpler now than the one I showed you in the PowerPoint. So all we have here for the strafing first is we're saying, okay, is this triggered? Add a movement input, world direction X, world direction Y, don't do Z. It's all based on the direction of the VR camera, and we're multiplying it by a speed. That's it, to fly like a bird or to walk. We don't even have to change much in order to toggle between those two options. And so what this looks like in order to still maintain that axis dead zone is I open this up, and you'll notice we got a little modifier. And the modifier here is just that. It's literally just a dead zone, and I can say, I only want this to work because the axis is from 0 to 1 if someone is moving the joystick past that 0.2 point. So they need to be more than 20% pushing their joystick in order for anything to happen. So that's a wonderful new feature that I think helps keep our blueprints a little bit more simple. And so that's happening there. Similar down here for walk, fly. You see I named these in a way that it's just helping me remember what's using X, what's using Y. But same idea down here. This is for moving forward. This is our world direction, just going on a forward vector. And down here, I also just called out the fact that this is what I used to have to do. Now that's no longer needed. So now that you've all seen that, I can just delete it. That's what was in there in the middle. Now we can go right past it. Here's how we're doing the scale change. So this, again, is an axis. We're getting the current world meter scale, which by default is 100. And then we're basically saying the more you're pushing up on your y-axis on your right controller, the more you're going to increase your size. And then we're popping into here, we're setting the world meter scale, and we are updating it with a little function that's taking your motion controllers and everything under them, hands, whatever, and the HMD, and it's all scaling relative to that world meter scale, and then I'm just playing a couple haptic effects to make you feel more like a god or something as you grow bigger and bigger and bigger. So back over into our event graph. That's pretty straightforward. And then there's that little reset that I talked about where the default value is 100, and we're just saying, hey, did you press that button? Great, then we're just going to update the scale, and your new scale is going to be 100. And then also we're actually going to do, this is a little more complicated, but we're going to do a little teleport trace the same way you do the teleport where you get a nice little arc. Now we're just pointing straight down, and we're saying, is the ground below us? Was I up in the sky like a bird? Now we're going to bring you down to the ground, and if you're flying, you'll actually snap to the ground. If your capsule component is actually working as a standard walkable component, then you'll be at the correct height when you snap down. So that's a little bit more complicated, but I think it's still worth pointing out. Here's our dash teleport. This one still pretty much looks the same. No need for an input action. This is being triggered over in teleport. So first we'll go through this, then we'll look at it inside the teleport node. So we're getting the player pawn and the actor location, and we're setting a start location. We're saying, okay, you want to teleport? Where are you right now? And then we just need to find where that projected teleport location is. I didn't even have to create a new variable for that. That variable already exists when you're doing teleport anyway. And now I'm lerping. I'm going from this vector to this vector over a set amount of time, and every frame of the way, I am setting the actor location instead of just at the start and at the end. It's happening the whole time. And so if I open up the timeline, you'll see I'm doing it not in a curvy curve way, because that will likely make people feel sick. I'm doing it in a very straight way, a consistent speed over a course of 0.4 seconds. And you could modify that or make that a variable and try different things. That felt good to me. 0.4 seconds of you moving from where you started to where you end. If you wanted to get more into the weeds of that, you could actually make it not a set amount of time, but make it based on the actual distance you're traveling. So if you're traveling further, you won't go there as fast as if you're traveling a short distance away. But I'm trying to keep things relatively simple. So the way you insert this into the teleport system is you find the function that gets called already in the blueprint called try teleport. And again, you don't even need to know how all this works. You just have to know this is the last step before teleportation happens. And so it's checking to see, do you have a valid teleport location? Hooray, hooray, hooray. The last step before teleport, this is where I'm just inserting myself. I'm saying, whoa, 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 hold on. Before you do an instant teleport, I'm just curious, just asking, just wondering, is our little Boolean for use-teleport checked? Because if it is, then before we do that, we really don't even need that last step at this point. Before we do that, we actually want to then go and trigger our dash teleport. And then it pops up to here and goes through there, which is pretty cool. And yes, I should have mentioned that I have Booleans for all these. They're all public. That's the little eyeball here. So we can make it very easy to set either in the editor or while playing the game, your move speed, your ability to fly, your ability to dash teleport, your ability to fade. Sorry, the fade on teleport is the fade to black, actually. And this is a little bit more complicated, so I'll go into this if we have time. But let me say briefly about the opacity thing here. The fade to black, Unreal Engine has built in a fade to black system. You can type in fade to black and something will come up. It usually doesn't work in VR. So the way that I tend to handle that, especially if I'm creating a game that has desktop and VR options, is I'll have both my VR and desktop pawns or characters derive from the same parent class that has what I'm going to show you right here over in the viewport, which is this fade plane. This fade plane is a very simple material, in this case unlit translucent, which is using a material parameter collection, no time to go into that in detail, material parameter collection with an opacity value that goes between 0 and 1. So when I need to fade everything up or down in my scene, I'm not relying on the built-in system in Unreal. I have everyone with this black plane right in front of them, which does have cost because it has translucency, and I am group fading up and down everything that is using that particular opacity parameter. But the short version is you got a fade plane. It's a big plane that's right in front of the camera, and as we change the material parameter collection value, I can do it right now. Scalar parameter, I could go ahead and turn this up to 1, and then I could go back into my pawn, and oh no, it's black, I can't see anything. Because the wonderful thing about material parameter collections is you can affect anything that is referencing that particular variable. It's also great for sequencers, and I've now spent far more time on that than I thought I was going to. So let's keep moving. All right, so down here, fade opacity, MPC opacity, that's all connected to that. And then, yeah, those are all of our public variables. So I think we've done our quick flyby of everything inside the event graph there, timeline. Here's that fade on teleport. And it's the timeline, I'll just say, I know I'm still talking about it, very similar to the dash teleport. We're just saying change that material parameter collection fade opacity using the name, the value, which is opacity, over a set amount of time. That's all. And yes, that's the event we saw before, where we say if you are going to be using the dampened spectator camera, we want to make sure that the camera isn't getting in the way of everyone. Or sorry, this is the other version. This is the one where we make sure that the headset isn't getting in the way of the spectator camera. So we just hide that in view. All right, so I'm hoping that even though I'm whizzing through this stuff pretty fast, there will be plenty of moments in this video where someone watching the on-demand version will be able to pause and like get everything they need out of this. So apologies if I go through some of the stuff fast, but I want to squeeze it all in if I can. Next thing, oh, actually, let me show you walking real quick. So when I click on my extended pawn here, which I keep looking for it where it doesn't exist. I could put it in the scene. I absolutely could. I would just need to make sure it auto-possesses the player. I'll just show you that real quick. Oh, and I should change the body to not be a gun. That was just a test. I'll show you why I was doing that test. But yeah, if I'm going to actually have it in the scene, I just need to make sure I have auto-possess player 0 down here. And then that's fine. I can use that one. And then I can make some edits that are very specific just to this. I could, turn off the hands or something. So with the capsule here, or sorry, when you do a character parent class, it actually asks you, what do you want the mesh to be for the body? And by default, it's nothing. And I was like, oh, what do I have access to for skeletal meshes? Because I don't actually have Manny or any of the default elements in here. So it was really just the gun. So I was like, okay, I'll throw in the gun. I could also just do a skeletal cube. But you could actually give yourself a VR body that way just by dropping something into that spot. So to toggle between flying and walking, you'll notice that there is a checkbox for use flying. And when that is unchecked, it is just going to be walking. The other thing you can do, really this is to give you the ability to fly rather than actually turning it on and off. By default, the flying is going to be way to ease in, ease out. So I would recommend cranking up that braking deacceleration to a high number. Otherwise, you're going to get pretty sick as you fly around because you'll stop flying and then you'll do like a slow down kind of thing. But we actually want to be able to toggle to go between flying and walking. And again, it's all going to use exactly the same commands right here. We don't have to change this at all. One is just using gravity and one isn't. We go to walking, and we have this here. So default land movement mode, and then flying. That's there too. So what we have at the beginning, right here, I added in a little sequence node after pixel density, which, by the way, pixel density, if you ever need a quick way to make your experience run at a higher frame rate, bring down the pixel density a little bit. If you bring it down to like 0.7, 0.8, not that many people will notice, and it's going to increase your frames quite a bit. And especially if you're doing Lumen and Nanite, experimental, don't do it in 5.1. Pixel density less than 1 is going to help you not crash. So the little extra sequencing I'm doing here is I basically say, if you don't say it's OK to fly, then it's actually going to use the default value, which is walking. So you saw when I searched under, here we go, just to show all this. I'll explain this in a moment. But when I did the default ground movement, or the movement mode, I'll just type in movement mode so we're being consistent here. Default land movement walking. There's our swimming right there. So we have walking on by default. But if we have can fly, or use flying rather, checked, then right at the beginning, it's going to go and it's going to change that movement mode from walking to flying for character movement. And then the other thing I'm doing here is I'm actually changing the collision profile to be overlap all dynamic. And the reason for that is it feels really jarring if you're flying around, free as a bird, whee, and then you hit an unexpected collider and you stop all of a sudden. So all I do with flying is I change the collision profile to overlap all dynamic, and then you can go through things and you're not as likely to get sick there. Otherwise, you will actually bump into things. So what I'll do here very quickly is open up. Actually, yeah, I don't even have to do it from here. I've got an instance in the scene, so I can do it specifically to this guy. I can scroll down, and I can see, as long as I'm at the top of that parent level, that I've got these public variables I can access. Move speed, use flying, use dash teleport, fade on teleport. So I'm just going to uncheck use flying, and I can I'll use VR preview because it'll load up quicker. And let's give you guys a dampened camera view so I'm not a monster. Or actually, you know what? We'll do the third person one here. And by the way, I didn't mention, like, you can look around, you can use the mouse wheel to change your field of view. You go around with the WASD keys, and oh, now I've gotten stuck in a wall. Fantastic. So what we can do is restart level, or I could just exit out, but this is fine too. So there's that. And now if my controllers turn on, now you'll notice that I'm not flying anymore. I've been grounded. My wings have been clipped. And I have to get a little bit shorter because my ground isn't quite at the right height, but I can move around without flying. And this, again, is on that spectrum of comfort options, less comfortable than something like dash teleport, but also feels more natural if you're not going to actually be able to physically move around. Again, best version is just you go for a walk while wearing a VR headset and you don't smack into anything. Cool. OK, hope that was helpful. And now I want to show you guys, with the time we have left, what it is like to create a new grabbable object. Because it's a real simple system. This hasn't really changed much in the past few releases, but I just want to make sure you see how it works. So you'll notice we got a bunch of grabbable objects. We got our ball here. We have this. And it used to be in the previous VR template that you needed to work with interfaces and do some stuff that was a little more complicated than what a beginner Unreal Engine user would want to use. But now, it's just a component. You can take any actor in your scene. We could take something that isn't grabbable right now, like this cube over here, just a regular static mesh actor. And we could go add grabbable, grab component. And then that grab component now, it's just going to ask us a couple questions. It says, hey, how do you want to be able to grab this? Do you want to make it so that when you grab it, the spot where you grabbed it from, that's the spot you're holding it from? Or do you want to make it so that it snaps to a particular location? By default, it's going to be the pivot point. So I grab it here, but my hand snaps to be in the middle because that's how we want to hold it. Then, of course, the more advanced version is you start to change the hand pose. So if you're grabbing a vase, it's like this. And if you're grabbing a ball, it's like this. But that's more complex. By default, free, snap, and custom are your options. But it won't work yet, because then what we need to do is we need to scroll down. You'll notice it already went from static to movable, so that's helpful. Oh, actually, I'm sorry, it did not. The grab component says movable, but we need to go up to cube and tell that to be movable. Otherwise, it'll be stuck in the ground. And then we need to simulate physics, at which point it can actually drop and bounce around and have weight. I could change the mass right here. And we have enable gravity checked right now. If I were to disable that, in fact, I'll do it just for funsies, I'll be able to actually throw it around. The other thing is we want to make sure We have overlap events, and simulation generates hit events, and that should work now, as long as this has collision. I do know this cube has collision. If you need to check, you can open it up, and you can go collision and look at the... Well, actually, right here is one way to do it, is if you see remove collision under collision, then you know it has collision. But I'm forgetting the new way to just view collision. It might be under show. Yeah, simple collision. So there it is, the little green box there. So that tells us it has collision. So watch this now. I go in, give you guys my dampened spectator mode. And it's right here. Oh, and it's just floating up like a magical bird. Not terrifying at all. But I should be able to actually go ahead and just grab it, right? And I can be like, oh, goodbye. And if gravity was on, of course, then it would fall back down. But, you know, maybe you're making a space game. I don't know what you're up to. So that's that. And yeah, I mean, that's really it. That's how you set up grabbing. Nothing too complicated there. And that's me just throwing things at the camera. I think everyone who realizes the spectator camera is like another player inside the experience wants to do that kind of throwing thing. So menu items. I mentioned very briefly that there are some simple ones. You can reset the HMD. You can go ahead and quit the game, restart the game. That's in there by default. It's very easy to add additional menu items. I'll show you that in a moment. And a couple examples of what I did. We were talking earlier about waypoints, where you saw it very quickly in the VR collaborative viewer with bookmarks. I think collab viewer is the official name of that template, where you were able to snap to different camera locations. So I basically just did something similar here, where there is a class of objects, actors inside Unreal Engine called target points, and I just set those up around a scene. And I said, okay, I just want to have my menu show me that I can jump to an interior location, an exterior location, and those can be placed anywhere. So at the beginning, with a UMG, you have your event construct, which is like begin play, and it goes through and it finds all of the target points that have a certain tag, puts them in a little bit of an array, make sure that they have a certain name. And then what we do is we have some new buttons, and I'll show you how to make the buttons that are casting to the player pawn using the fade toggle, the same one we're using for teleportation. So you fade out to black, and then you fade up, and you're in that new location wherever it might be in the project. And we're just using the standard out-of-the-box teleport. I could also set the rotation if I wanted to be consistent, but there is actually something kind of cool about just pointing in whatever direction that you've set up with the target points. So that's one example. The bottom one is another one. Stat RHI, stat FPS, stat unit, stat GPU, stat detailed. These are all things that you might want to pull up while you're doing VR to just give you more information about how everything is performing. So I just added a button that lets me pull that up and off on the fly. And fairly recently, I think it just happened in 5.0, now you see the console log in VR at like a fairly comfortable distance. It used to be, you couldn't quite see the corners and it was too close to you. Now it's actually quite readable. So let's look at that real quick. Oh, I still got this guy up. We can close you. Although actually, here's where I've got the target point, so I'll just show you that real quick. So I've got target point exterior right here and target point interior right here. And so that's what gets created for the buttons. So yeah, I can just type in menu. There's menu final. And so all I did to add these buttons, because again, it was just a restart and a quit. Now the new one again has reset HMD, but you can literally just duplicate one of these. Like, let's add a new one now. So I could go ahead and duplicate that. And you'll notice it takes the text along too. And I don't know which one is the original. Probably the one that says the number 1 on it. So I'd call this like new thing I want to do, whatever, some kind of placeholder. And then I'd want to change the text to new thing I want to do, or whatever. And you'll notice it's making all the buttons bigger. The UMG system has all sorts of nice, like, auto-fit kind of stuff going on. And then all I have to do is click on that button, not the text, but the button, and then I can scroll down, and then I can say, hey, when someone clicks that, I want something to happen. So we press that plus, it creates this new little event, and then I can say, the thing happened, or whatever. And now I've made a new button that will actually show up on my menu, because this is literally the menu that spawns whenever you press the menu button. By default, and I want to show you this in the new template because it's different from how it used to be, when I go into here and press the menu button and I go into the not shaky mode, that floating cube back there, it's amazing. It's kind of malevolent too, like there's something about the way that it's just slowly rising up. I feel like I have to keep like turning around and be like, what's gonna happen? Is it gonna explode? Is a ray of sunshine gonna come out of it? Who knows? But if I press, now it is the B button and the Y button. You can also use the Oculus menu button, but that's a little trickier with SteamVR, and you can't use the menu button down here, so I think the intention was to just make it really easy. So you're spawning it on either hand. One thing you could do is you could take, I'll give this a little bit of homework, you could say. You could take the same technique we used for the spectator camera, dampening the view you see right now. Oh, and you guys can't really see the menu. There it is. And by the way, I can move the joystick to click something and pull the trigger like that, or I can pull up the menu and get a nice little ray pointer here. So I like having both of those options available. But you could take the same dampening technique that we have with the spectator mode, and I just realized you can't see what I'm seeing. Let's go there. There you go. So yeah, so pointy point, click, click, click there, or I can just use my joystick on my left hand and pull the trigger and do things that way. So what you can do is take the same technique that we did for dampening the camera, and instead of spawning that menu right there in front of you, you could have either button, pressing the menu button on either side, spawn the menu right in front of you. And rather than having it always directly in front of you, you could dampen it. You could have a target point that you're telling the menu to spawn at, and then you could just kind of, have it be chasing that location, and that might be like a nice, comfortable, big menu right in front of you, which is going to be useful if you want more than just 3 or 4 buttons. You don't want like 30 things pulling up like right there in front of you. Maybe it's okay if it's larger and directly there. So I'll just show you very, very quickly without actually going through the blueprint how you could get started with something like that. I'll type in menu. And actually, so that's the menu, but then it spawns over in our pawn. So ext, our pawn extension. And we've got a function that gets called for toggle menu. So toggle menu right now, it spawns the actor menu at a 000 location, and that reference is actually going toward the widget interaction spots here. But instead, you could actually have a specific location. So when that spawn happens, the spawn actor menu, that's where you could tell it to be at a certain location and then be constantly on event ticks, setting it to be at some kind of target point. So if anyone does that on their own and they're proud of it, find me, Ibrews, IBREWS on Twitter, and I'll give you a prize or something, because it's always fun to see people do a thing that I told them they might want to do. Okay. Moving on, that's the sun study I mentioned, being able to watch the sunset, very cool. Packaging, we kind of already covered this, but I'll just mention that you can have everything set up for these different platforms like I was showing you, a low, medium, high-end version, but you do want to make sure you change the game default map. This is packaging 101, but if you've already made everything work great across those different maps, when you actually are saying, now I'm making it for Quest, now I'm making it for high-end Windows or low-end Windows, that you have that same map set up. The more advanced technique, of course, would be you have everything all happening in one map, and then you have all sorts of switches and knobs that happen on begin play that are detecting what the capabilities are of the hardware and turning bells and whistles on or off based on that. I think that gets a little bit complicated. It's easier, in my mind, to just do it as separate maps. And maybe they share like a sublevel or something for the things that you know are going to be the same across everywhere. With the time we have left, I do want to have a little bit of Q&A, and I'm the last session, so we can like keep chatting for as long as anyone wants to. Some VR best practices. I do want to show you guys Lumen and Nanite, so I'm literally going to hold these up on screen for like a second. So again, on the replay, you can look at some stuff. Can you simulate VR without an HMD? Yeah, you can use console commands like emulate stereo, things like that. If you make the screen percentage higher, that simulates oversampling. That's useful. Note that when you're using SteamVR, you can simulate input in different ways. There's that Vulkan preview session I mentioned. Some optimizations we can do. Sorry, guys, this is definitely more for the recording than for you. Settings with level of detail. Mesh optimizations you can do. The LOD system that Unreal does out of the box is actually pretty great. So if you just tell things to be high detail, it's going to create a ton of different LODs of everything you have. Material optimizations, how expensive are materials? Translucent is very expensive. Try to use the same parent material if you can. Your material nodes can also have some switches based on settings, some different texture optimization. Generally use a power of 2 so it can create MIP maps. Things can look kind of fuzzy if you don't have MIP maps. Here's our optimization view modes for light complexity and stationary light overlap. Too many stationary lights are bad. They won't work. Lighting optimization, static when possible. Quad overdraw, don't have too many quads overdrawing because then you're wasting precious time and energy. Cull distance volumes, great. Merge actor tool, great. Hierarchical level of detail going on to the next line. Another great tool. Sorry, that'll be hard to read even on the recording. That's how that can look. You guys are troopers to just let this all wash over you. Packed level actors are a new system in Unreal Engine 5 that just lets you have everything go into a level. Some CVARs. The one here that I probably use the most is pixel density or changing the spectator screen mode. That is different from the spectator cam we have here. It's literally for what you see of the VR view. You can change what that looks like. There's what changing the pixel density is like. It's a lot like screen resolution. Here's a bunch of system settings you could start with. I should give you guys the actual text of that, so feel free to PM me if you want any of that. Some of those profiling commands I like to do, stat unit. Okay, here's the fun part. Initial lumen. Yeah. Right, with 3 minutes left. So, I'm obligated to say, it's experimental. It is not fully supported. It's not stable. Don't use it. But it is very cool when it is working in those little moments of bliss to be able to have real-time reflections, real-time GI, moving light, incredibly detailed scenes, super, super cool. Right now, only works on desktop, only works in deferred rendering, and at the moment, you might not actually even see performance gains over doing even a ray-traced version of that same scene, so just be careful. The way you need to set it up is very similar to how you would set up any kind of Lumen Nanite project. You want to uncheck forward shading, you want to make sure you're using shader model 6 for Nanite, you want to be in DirectX 12, you want to make sure you have mesh distance fields, virtual shadow maps and textures, virtual shadow maps there. Oh, and actually, one thing I've noticed too is, sorry, just flicking through these. Over here, when you set up Lumen for your dynamic global illumination method and your reflection method, make sure your reflection capture resolution is low. In my experience, if I make that too high, which I normally would make it high for when I'm baking my reflection captures, instant crash in editor, not sure why. But again, we're not stable here yet. And I generally wouldn't even enable hardware ray tracing. That seems to have some problems too. Definitely go ahead in Oculus and lower the VR pixel density to have any kind of stable experience. I tend to add some little buttons for increasing it until I crash, and I'm like, okay, I guess 0.8 is the best I can do, and now I know. With SteamVR, I'm sorry to say that anytime you try to change the resolution, either with pixel density or screen percentage, not going to work. So you have to have those set at 100%. And you also need to use sorry, I didn't write this down. You need to use a parameter, no RHI thread, in order to not get some very weird shadow artifacts. Again, buggy, experimental, being worked on, going to get better. Over here, there's just some mesh optimizations, basic stuff about Nanite. There's some supported features, unsupported features. Nanite now does support foliage and VR, of course, to a certain degree. Does not support the things on the bottom yet. And yeah, if everything goes well, you end up having an experience like this particular time where the entire time this was happening, I was like, it's working, it's working. I have trees everywhere and all these scenes from the Matrix demo. And I'm like, it's going smoothly. It's running on my laptop, which has a mobile 3080. And I can turn on the Nanite mode and be like, look at all the geometry. This would never render in a normal way. And it was all bliss. And I've had this successfully happen maybe twice. Usually it'll crash pretty quickly. But it is very cool when it is working with reflections and all sorts of cool stuff happening like that. So I'll just let this keep playing for a moment. Let's open it up to questions with a little bit of time we have left. And then, yes, of course, if anyone would like to try this demo for yourselves, it actually does run pretty well on the computer right here. So I'm happy to share it with you. But look real quick, just like that detail of like all the little architectural things in there. There's no LODs in this. It's all nanite. And it feels really, really, really good. So I'm really looking forward to watching all that improve. This is sped up at this point because I just wanted to, I'm like pretending that's like a locomotion technique. It's not. I'm pretending to be a locomotive. That's all that's happening. But yes, anyway, thank you very much. I'll show you how to get a hold of me.